Russian physicist Heinrich Friedrich Emil Law, who initially proposed Lenz law in 1834, is honored by having his name given to the law. The underlying concept of Lenz law, however, were established over time by a number of scientists working together. Thus, it is crucial to keep this in mind. Lenz law has its roots in the research and tests conducted in the early 19th century by Michael Faraday, a distinguished scientist.
The knowledge of the interaction between magnetic field and electric current was made possible by Faraday's research on electromagnetic induction. Electric motors, generators, transformers, and electromagnetic braking system are just a few of the devices where Lenz's law is put to use. It offers a fundamental knowledge of the behavior of electromagnetic field and is an idea in the study of electromagnetism.
Lenz's law is the fundamental principle in physics that describes the direction of the induced electric current in the conductor. The law states that the direction of the induced current is such that it opposes the change that produces it. In other words, the electric current is induced into a conductor when the magnetic field surrounding it changes. The direction of the induced current is such that it produces an opposing magnetic field to the one that caused the magnetic field change. This can be understood by considering Faraday's law of electromagnetic conduction, which states that the changing magnetic field induces an electromotive force or EMF in the conductor.
According to Lenz's law, the induced current in the conductor flows in such a way that it creates a magnetic field that opposes the change in the original magnetic field that produced the EMF. Lenz's law has many practical applications, including in electric motors, generators, transformers, and electromagnetic brakes. It helps to explain why, for example, a moving conductor in a magnetic field experiences a force that opposes its motion, and why a changing electric field induces a magnetic field that opposes the change.
According to Lenz's law, the direction of induced current must oppose the change in magnetic field, for which induced current flow counterclockwise. Lenz's law says the direction of induced current will oppose the change in flux that created it. It is not a matter of increasing and decreasing, it is a matter of direction. The direction of induced EMF drives current around a wire loop to always oppose the change in magnetic flux that causes the EMF. Lenz's law can also be considered in terms of conservation of energy. If pushing a magnet into a coil causes a current, the energy in that current must have come from somewhere. If the current were induced in the other direction, in addition to the heating effect, its action would also spontaneously attract the bar magnet into the coil, which would go against the law of the conservation of energy. There are many differences between alternating current and direct current. Alternating current oscillates in two directions, and direct current has a constant magnitude over time. This is due to the mechanism that generates AC, which is rotating coil between two magnets.
One of the components of Lenz's law is alternating current. We all know that Lenz's law conception is when the source of EMF is connected across an inductor and a current starts flowing through it. Now this flowing current has work done. Lenz's law also tackles electric generators wherein current is induced in generator and the direction of induced current opposes and causes rotation of the generator. Now when the direction of the current changes periodically, it is called alternating current. This alternating current or AC's magnitude and polarity changes over time. Mostly this current is electrically charged. This direction of current moves forward and backward or alternate. Alternating current converts high value to low value and vice versa with the help of transformer. In this stance, alternating current is more on transmission and distribution. For example, the induction stove has alternating current wherein the current of electric charge flows in the coil and vice versa. This alternating current of induction stove is converted into high value to generate heat. Once it produces heat, this heat goes to the surface of the induction stove. And that's how alternating current or AC works for Lenz's law.